Okay, this is Giancoli chapter 5, number 13. We're trying to find Mars. And remember before, I derived that remembering when we had the gravitational force was equal to the centripetal force that we needed. And remember we got Gm over 4 pi squared was equal to r cubed over t squared. And since this whole thing's a constant, this has to be a constant for central body. So what we're going to do is we're going to use this, exploit this to figure out. So what we've got is, we know Earth. Here's Earth. Here is Mars. And what we're trying to find out is how far is Mars away from the sun? And what we say is we know that the r Earth over, oops, that's supposed to be E, r Earth t squared Earth, and that's cubed, has to equal our position of Mars, and that's what we're looking for, over the time that takes for Mars to go around squared. So we can say that the radius of Mars cubed is equal to time of Mars over the time of Earth squared times the radius that Earth has cubed. And then we take the cube root and we find both sides. So what does this give us? The radius of Mars, just putting in our values. The time, what they tell us, the 687 days. 687, that's for Mars. Divided by 365 and a quarter for Earth. Times, now what do we have? We could have used days, I suppose. Okay. And what else do we want? The time. That's the time. Oh, and the radius of the Earth. We can just take that for mean distance from the sun. We can just take this one, 1.49. 0.6 times 10 to the 6 kilometers. And don't forget that's going to be squared. We got to square. Oh, cubed. Sorry, cube that and cube that. So we find that our distance to Mars is 687 divided by 365.25 and 1.8. That's what they told us. We have to square that. And then 149.6 times 10 to the 6, and we have to cube that. Multiply that, and then take the cube root. Let's see if this works. Flip it over, raise it, 227, 227, let's call it 228, 228 times 10 to the 6 meters. That's where Mars we think should be. Where is it? Pretty darn close.